So this is our project, Matrix Dynamics Explorer. It's by myself, Kevin Murray.
And I'm Tim Wikinski. All right, so for the basic info, the first thing to understand is that uh, as a fixed point, which a fixed point is a function that for a given point maps onto itself. For example, if I have a function where f of 1 equals 1, that means 1 comma 1 is a fixed point for that function. And one method for finding fixed points is called the iterative method, where essentially you the starting point, you plug that starting point into the function, and then take that value and plug it back into the function. You keep doing that until a fixed point is found. And the idea of our software is the user can run it on that method for a function on a starting matrix or a more, and essentially it outputs the certain values for the users, like the final matrix, the eigenvalues and vectors, and the plot of the change in values per iteration.
So just to understand who our client is Dr. Timothy Clark. He is a teacher here in the Department of Mathematics at Loyola, and he received his PhD from the Department of Mathematics and Statistics at the University of Albany. He plans to use our project to help with his research, as our overall goal is to attach our application to his school website so that others are able to use it.
All right, for technology, our backend's in Django, which is a Python framework. And in order to perform the operations on the matrices, which was one of the key aspects of our project, I use the NumPy library, which is one of the largest libraries for these kind of operations. And we use Pandas in order to read from input user, CSVs about the user. And we use PyTest for our testing.
So here's a simple picture of our package diagram. We used an MVC architecture through Django, and the controller is divided into view, which is poorly named from Django's end. It really refers to the event handler, and the controller handles the business logic, while the template itself is more of the view itself.
So for stories, we did 56 story points, and we didn't quite finish all of our stories, and we have about 5 story points left. Because a few of our stories were a lot harder than we thought, so it ended up not quite being finished. Although the core features of the app were all finished.
So now we're going to do a live demonstration of our application. We currently have it running on my localhost 8000. So I'm going to load that up. So as you can see, there's 3 possibilities for input. You could start with a starting value just as a number. You could start with a starting value as a matrix of a size of your choosing, or you could import a file of multiple matrices to start with. For this one, we're going to do the polynomial 2x over our starting matrix of random values. And we will do 8 iterations at a threshold of 0.2, which says if the norms between matrices goes below 0.2, we can assume convergence and can terminate the calculation. So now that it has completed all 8 iterations, we can see that the value ended up diverging. And we can see output to better understand how it diverged. So as you can see here in the graph of our norms versus iterations, we start out with very low norms, which makes sense. And then as the iterations continue, the difference between the matrix and its previous matrix is much greater. And we can also see reflected in our eigenvalues, which shows each iteration how the eigenvalues differ. So now we're going to go back to our main screen and do an example where it converges rather than diverges. We will do values less than 1 within our matrix, and we'll use the polynomial x to the 1.2. We will do this for 9 iterations, and we will check with a threshold of 0.1. Now, as I forgot to show earlier, there's also a verify polynomial option, which will just show if the string that you inputted can properly be parsed into a polynomial. So now that we can see that the matrix does converge, and we can view the output to see that. So we see that the norms are progressively getting smaller until it is almost zero, which shows that it is converging upon a point. And that is our application. Thank you for watching.